This video is part of a narrated series that's designed to sit alongside the A-level chemistry speedrun series of shorts I made. So in these videos I'm just going through each exam question a little bit more slowly and talking about why it is that I've written what I've written for each step. This question is taken from the redox topic, which comes at the very end of AS physical chemistry. And in it, we're asked to come up with a couple of half equations, one that's really straightforward and one that's a little bit more complicated, and then to combine those two half equations to make one overall ionic equation. So first off, let's look at this ion. We're told in the question that Fe2 plus ions are turning into Fe3 plus ions. So that's where we need to start with our half equation. Now, because these are just monatomic metal cations, it's really straightforward to see that we've got an oxidation state of +2 turning to an oxidation state of +3. And then we need to use electrons to balance out those oxidation states. Now for this first one, the oxidation state and the charge on the ion are just the same as each other, but it still bears mentioning that we are balancing oxidation states, not charges, because that's going to be important in a minute. So here, in order to make +2 balance with +3, remember all I can do is add electrons, and electrons have a negative charge. So I'm going to need one extra electron on the right hand side of my equation. So I've got +3, take away 1, that's equal to +2. Nice and straightforward, all done here, nothing else I need to do. Now the second equation is going to be a little bit more complicated. So we've got our manganate ion and we've got our manganese 2+ ion. So once I've written those in and left some gaps, because there's going to be some other stuff added in a minute, I need to work out what the oxidation states of the manganese here is. So obviously the right hand side is quite straightforward again, because I've just got this monatomic cation, but on the left hand side I need to work for it a little bit more. So as long as we don't have a peroxide, which we don't here, then oxygen is going to have an oxidation state of -2. And I've got 4 oxygens, so -2, -2, -2, -2 makes -8. But overall, the charge on my ion is only a single minus charge. So therefore, I must have 7 positives balancing out 7 of the negatives from the oxygen in order to just be left with 1 negative. So my oxidation state for the manganese in the manganate ion is +7, and then in the manganese ion it's just +2. So now we need to add some electrons to make these balance. And like we said a second ago, we are balancing oxidation state, not charge of the ion. So we're not going from -1 to +2, we're going from +7 to +2. Okay, and remember, we can only add electrons. That's all we can do. They're always electrons, it's always -1, and I can only add them, I can't take them away. So I need to add 5 negative electrons to the left-hand side of my equation to make this balance. So I'm going to add those in. Okay, so now that that's done, now my charges aren't balancing. So now I've got this single negative charge on the manganate ion plus another 5 negative charges on my electrons. That makes 6 negative charges overall. And then I've also got this manganese ion on the right hand side with a 2+. Also, I've got 4 oxygens on the left that aren't on the right. So I'm going to solve both of these problems by using some hydrogen ions and some water. So it's probably more straightforward to do the water first, because you can just see, oh, I've got 4 oxygens, therefore I'm going to need 4 waters, which gives me 8 hydrogens, which I can then add back in on the left hand side. But in adding those 8 hydrogens, I've also sorted out my charges. So I had 6 negative on the left, I've added 8 positive, that gives me 2 positive left over, which is what I have on the right hand side. Happy days. Now I need to combine these equations. So this is quite a straightforward question. Actually, my 2 equations are already the right way round. They've told me in the question what's going to happen here. But I'm going to need the electrons to balance. And right now, my top equation, which we're going to call number 1, only has 1 electron, and my second equation, which we're going to call number 2, has 5 electrons. So that's no good. I can't just mash these 2 equations together. So what I'm going to do is I'm going to take equation number 1 and I'm going to multiply it by 5 in order to make these balance. So that turns that into 5 Fe2 plus ions goes to 5 Fe3 plus ions and 5 electrons. So now I have 5 electrons in both equations and I can jam them together. So if I write out everything from the left-hand side and everything from the right-hand side, I've got electrons on both sides of the equation, and that's silly. I don't need electrons on both sides, so I'm going to cancel those out like that. And I would do the same thing if I had two equations that had water molecules, so they were on both sides, or hydrogen ions on both sides as well. I just want to get rid of anything that is repeated, because there's no point in it being there twice. Thanks very much for watching, and if you are finding these useful, then don't forget to like and subscribe for more A-level chemistry coming soon.